So now we're ready to start defining parts of the domain and really figuring this out, opening up some existing apps and playing with, the idea of what now is going to make this application. I know a lot of you are excited to just get coding. So we're going to jump in and do something that I know is absolutely required, which is to communicate with Bluetooth devices. A lot of these glucose readers are Bluetooth devices. So we're going to jump in and code that today. So the goal of this video is to start with the basics of Bluetooth, which is firstly to create a test project and get it up and running so we can discover Bluetooth devices. Make a nice clean class that handles this or several classes and keep it so it's in nice small chunks and easy to test in the future and easy to, merge into our domain once we're happy with it. So instead of trying to define an interface of what we want Bluetooth to do, I honestly don't know right now. I haven't interfaced yet with the actual Bluetooth devices. So instead, we're going to make the concrete implementation, get it up and working, get it talking to one of these glucose monitors, and then we'll extract an interface from that we put into the domain once we're happy that we know what we're doing. Whereas right now we're unsure. So this is the way around to work. Get something working, then define the interface afterwards. And that will be probably the same for quite a few areas of this application. So let's just jump in. So I started with the obvious, which is a quick Google on Bluetooth and generally .NET Core or cross-platform. And to save the wasted time of showing you just a bunch of Google searches, what I discovered was there's really no library or something I'm happy with. Looking at what's out there, looking at some reviews, looking at the existing NuGet packages, what I feel is going to happen instead is we're going to have to make one Bluetooth client, if you will, one Bluetooth service for Windows and one for Xamarin. And then if we need it for any other platforms, we'll make it that way. So I don't think there's really a shared Bluetooth library. Instead, I'm going to make one and then distribute it freely online as probably a separate NuGet package. But for now, I'll just bake it into Blueberry directly. So the result of that is we're going to start on WPF, as I mentioned, for quick and easy debugging. And when I looked for how to best get Bluetooth on Windows, I don't really intend to support anything less than Windows 10 these days. Windows 7's gone out of support now. Windows 8 was terrible. I don't think there's any need to support anything less than that to stay modern. There's too many downsides to trying to support legacy operating systems. So with Windows 10 in mind, what I found was we've got this UWP code here, reference code, or rather documentation about what's available in UWP. We can pull this into WPF no problem, and I'll show you how to do that in a second. So what I've seen is that they have this Bluetooth Low Energy documentation here. I'm presuming the devices as well are Bluetooth Low Energy, based on the fact that the small devices, I'm certainly hoping they're not all Bluetooth. So we'll start with a Bluetooth Low Energy class. Reading this documentation, it gives you some basic insight and what your class as a client and a server, and the GATT. So I'll give you a brief overview. You can read this. I'll leave this link in the description. What it talks about is that servers are the things which also is confusing here, where it puts wearables getting notifications into clients. It's not talking about the Bluetooth monitor style devices here. It's more these sensors. So the Bluetooth glucose monitors are classed as sensors, if you will, and they are servers. They're the things that are broadcasting the information. And the client in this case is us, this Windows computer. So the one thing I feel is important to mention is this GATT, which basically just means it's like a description of what it is it's going to support. Like in this case, it's going to support a heart rate service or a body sensor service. So you can almost think of it like an interface. And in Bluetooth, when you listen out for devices, they will then tell you about the GATT. They will tell you what they support, what type of device they are. So then you know how to communicate with them. And each device can have its own communication standard. It's not like it's universal, it's basically generic. You connect to a Bluetooth device, then you try and talk to that specific device by understanding what it's saying. So the client and the server, as I mentioned, the client is us and the server is going to be the device. And we will need to connect to it, but firstly we need to discover it. So that brings us on to watchers and publishers. So publishers are the things that are going to advertise their availability. Again, like the actual Bluetooth readers, they will publish and broadcast that they're available. And we need to watch that. So what we need is a watcher. And what this documentation recommends then is this Bluetooth ALI advertisement watcher. So if we open that in a separate window, we can see this is what we're going to want to use and consume from the UWP side. So we're going to make a reference to that and instantate that. And then we'll come back and figure out all the rest. We'll basically code as we're reading and figure out as we go. So if we come over to the Blueberry project, you can see here core, Blueberry core is what is going to be our domain. This is what will have all our domain specific code in. As I mentioned, we're not going to define the interface yet that will go into core, that will go into the domain. We're just going to make the actual implementation at this point of the Windows Bluetooth. So that will be in the desktop project here. But instead of combining it directly in this, Windows project, we'll just keep it in the overall folder, and we'll make a new one that's blueberry.desktop.windowsapp.ble for Bluetooth Low Energy. So we're going to make a new project. So if we right click on the folder, add new project, we'll make it a class library of .NET Core. And then in here, the name will be blueberry.desktop.windowsapp. We can just call it Bluetooth. We could even call it wireless, but let's just call it Bluetooth for now. And that's going in the source folder, which is fine. Create that. And then this is now the library we can start using. Let's just right click on dependencies now and add a reference. And if we go to browse, then browse here. Where you want to go is program files, x86, then I think it's Microsoft reference, somebody with references, reference assemblies, there we go. Microsoft framework, it's .NET Core, and then if you've got 5, nope, still on 4.5, so 4.5, and then in here what we need is the interrupt services for Windows, the Windows runtime, and this allows us to access WinRT, which is UWP stuff. So if we add this to our code, and then finally we add a reference to the actual UWP side of it, go back up to program files, Windows kits, 10, where was it? Union metadata, I think it's in, and then your version might differ here. This is your Windows version, and reference the actual Windows file here. Those two classes then allow us now to get access to UWP stuff. So it obviously means this specific library here, this implementation of Bluetooth, is hard-coded to Windows because we have references on Windows. That's perfectly fine because this is going to be injected by the Windows app only. So don't worry about that. That's how it's meant to be. And then in this class, say, let's just see if we can find the Bluetooth Ali, what was it called? Bluetooth Ali Advertisement Watcher. Control dot, and there you go. You can access it through Windows devices, Bluetooth, and advertisement. So now you can see that's referencing here. So anything we see in here now, we know we can reference and where it is. So if we were to press F12 on this, you can see that it's dug in and it's come from this Windows MD file we're referencing. So that's where it's coming from. So that's perfectly fine to do. There's nothing wrong with this approach, and we can now use code that's in UWP to our benefit while we're inside a WPF application. So we have the advertiser, and we will want to make our own class to wrap that advertiser to make it nice and easy to consume. So if that name is Bluetooth Ali Advertisement Watcher, we want to try and keep it obvious that we're just wrapping that. So we want to call this the Blueberry Bluetooth Ali Advertisement Watcher. And then it's going to get quite a long name, but it's descriptive, and it shows that it's a clear implementation of this class. The other thing we could do, because we're going to make this generic in future and make it its own version, we have the DNA framework, which is open source, and I'll probably put it in DNA framework as a DNA framework.bluetooth library. So instead, what I'm going to do is call this DNA Bluetooth Ali Advertisement Watcher. And when we're happy that this is fully implemented and working, I'm going to move this into the DNA framework library that can be referenced. It's going to be separate NuGet package that can be referenced in this project. So that's how we're going to name this. So let's name that class and rename the actual file to match. And we now have this class. Remember to comment as we go. The namespace is fine in this case. We can always rename it. There's only going to be a few classes. Wraps and makes use of the, and then we can cref the Bluetooth Ali Watcher And because we don't have it, because I've just removed it, in the namespaces, I press Ctrl-RG to clean them up. Put that back in a minute. Wraps and makes use of the Bluetooth Advertisement Watcher for easier consumption. That's that. We will want the private region for the private members. And we know we will want one of these Bluetooth Ali Advertisement Watchers, and we'll call it Watcher. The underlying Bluetooth Watcher class. I might be a bit slow at typing on this one. I've changed keyboards again. Constructor. And then in the constructor, a note on constructors. One good thing about starting to read a few of these books again to try and help with some recommendations on good books is it kind of refreshes your memory on things that you should and shouldn't do. And one of the books I read, I believe it was the Dependency Injection book, reminded me that constructors shouldn't really do anything except construct the class. You shouldn't do any kind of logic. You shouldn't spin off tasks that start loading things that we're very often doing and common to do. You should try and keep it clean and then define some kind of interface that handles how and when you should load things or do things on the side. So with that in mind, I want to keep my constructor clean of any kind of major logic. It should be about construction. So one thing we know we want to construct is the watcher. So I'm presuming we just make a new watcher. And we can pass an advertisement filter, or we can do nothing with. So let's have a look at some properties on there. Advertisement filter, scanning mode, signal strength, and status. So let's just take a look at the documentation, see what it says about those properties. Advertisement filter gets or sets the filter for configuration of advertising filters. Don't think we want any filter right now. Maximum timeout range, maximum sampling, timeout range, sampling. So again, to start with, I'm not really bothered about any of these. We just want to get it up and running. Scanning mode sounds interesting. Let's see what that is. Scanning mode is active. This indicates that scan request packets will be sent from the platform to actively query for more advertisement data of type. Scan response. It specifies the different types of Bluetooth advertisement payloads. Scan response. This advertisement is a scan response to a scan request issued for a scannable advertisement. This advertisement type can carry data. This corresponds with scan. So that's one thing I think we're going to learn as we play with it. It's not really descriptive enough for me to know what that's talking about, but I do know that active sounds more aggressive than passive. So I'm going to go with an active scan mode, and then we can hopefully see some devices. Come on, IntelliSense. What's going on with IntelliSense? There we go. And now let's see what else is on this watcher. So we have the timeouts we saw, scanning mode, signal strength, status. So we've got a received event, a stopped event, and a start and stop. So it seems fairly obvious what we do here. Start the watcher, stop the watcher, listen to two events. I don't think it gives any examples on here, but it seems fairly straightforward. This might give some information. Advertisements. Advertisement watcher, is that where we are at the minute? Is that gonna? Yep, that's back to where we are. Basic setup. So create, that's a publisher watching. So create a watcher, listen for received, and start. So let's go in here and listen for receiving. And we'll call it watcher advertisement received. Oh. Listen out for new advertisements. listens out for watcher advertisements. The watcher, the arguments. So in there, we don't know what we're going to receive yet. So we can just put a breakpoint there and see what we receive. I also want to listen out for the other event, just so we've got a complete package. So we'll listen out for stopped events. I think it's the same as the other. Watch run events. Yep. So I'm not sure what to do with that yet, but we will do something. In fact, we could just add an event. Let's just add an event. That's easy enough. Just exposes this to the outside world. So when people want to consume our specific implementation, we're not hiding stuff that's, you know, possible with using the actual native one. So I'll have public event stop listening, and we'll set a default so that we don't have to null check it. What am I doing wrong there? Oh, I haven't specified the type, just an action. There we go. So, fired when the Bluetooth watcher stops listening. So we can now just do stop listening. Sure, IntelliSense has messed up on this machine. There we go. Listen out for stop events, or for when the watcher stops listening. And then, as mentioned, what I would normally do in here now, in my eyes, is just go watcher.start. But because the constructor shouldn't really do anything specific, it should be, you know, started afterwards, we will do that separately as a call. So the consumer has to start. It also then follows the same pattern as the underlying class. It doesn't change the behavior too much. But we'll actually say start listening. So it's a bit more descriptive than just start. In this, we'll also want, thinking about it, a flag to indicate whether we're listening or not. So public properties, public boolean listening, it's a getter, and it can be the watcher. Status, I presume, will have something to do with status. So it's similar to any event that's kind of starting. So in that case, if it's listening, we're only listening if it's started. That's the only time we're listening. So indicates if this watcher is listening for advertisements. Another thing also is I want to start making more use of like the read-only. Again, coming from reading the books, it makes you kind of refresh your memory on certain things. I rarely use read-only, so it would be good that we only want to create this class in the constructor, and we don't want to be able to then unset it. So we can be assured, like here, it could never accidentally be null. So if we mark this as read-only, then in the constructor it's set, it can now never be unset because it's been set once, so this null check's never needed. So that's fine for us, and you can't access this property before constructing, so it's fine to do that. So then in the starting, if already listening, and I think if we're already listening, it's fine to just do nothing more. Then if we just do mwatcher.start now, start the underlying watcher, and we should have another event, I think, to inform listeners that we're actually starting. Fired when the Bluetooth watcher starts listening. Started listening, default, and in here started listening. So that's enough to start listening. Now we want to consume this and do something with it. I don't know whether just to have a console app for playing with for now that we just spin up, or whether just consume it in this Windows app. I might as well just consume it in this Windows app for now. But then again, this is the actual app. So because I'm not bothering with unit testing for now, and I'm also not a fan, I think we want to kind of just a console test app. So I'm just going to quickly make another new project. It's going to be a .NET Core console project, and it's going to be called Blueberry dot. It's in desktop for now. Console playground. Why not? And now in here we can add a dependency to our Blueberry there, Bluetooth I mean. And then in this now we should be able to do var watcher equals new DNA Bluetooth. I can't be bothered to type that big long name. One of those. Control dot. Add that. Make a new one. And then hook into the events. So at the minute we have start listening. Doesn't give any events. That was the underlying one. We'll do console dot write line. Yeah, this new IntelliSense is no longer highlighting the default action. We have to press down and tab. It's making coding a lot slower. So this will be started listening. Do the same for the stopped. At the end of the console, look like that. It's not selecting it. So if I press tab, let's work that time. Yeah, it's working now. Maybe it's just this new keyboard. So don't close. And then here, watcher.start listening. That should start it. New watcher. Hook into events. So that's consuming it. We can set this as the starter project so we can start playing nice and easily. Set a starter project. And before we can do much with that, well, let's just add the stop method as well. Public void stop listening. Oh, we never finished that comment. Starts listening for advertisements. Stops listening for advertisements. And again, if we're already listening, or if we're already stopped, so if not listening, then just do nothing again. Well, this new keyboard's getting hard to get used to. And then similar to the other one, stop listening. And that we don't need to fire in informal listeners like the start, because I'm presuming, and we'll see, if the stop, it should fire the stopped for us because it's got an event. So we'll have the start and the stop. Now we've got when we actually get data here. And I don't know what info we get. That's the watchers, that's ourselves. And the events normally has its own args. So let's just take a look at args and see what we've got. And we could also look at the documentation, I guess, if we went to here. And went to the events of received. Then go to the event args. And here we go. So advertisement gets the Bluetooth advertisement payload received, gets the type of the received events, gets the address, gets the signal strength, get the timestamp. So I think what we want to do is to extract this information into our own class so that we can actually, you know, create a class from this and send it off, and that's what we broadcast as what we've received. So there's a Bluetooth address, an advertisement type, which is, that's the one that's doing me head in. When you do that and then press dot, because you're happy with the default, it should normally select that and then pop up, and that's changed now. Has anybody else noticed that behavioral change? Because that's really frustrating. It's an extra step. So there's the types, there's that scan response thing. So these are the types of advertisements we can get. So we want that information, and we'll also want to, well, I'm not really bothered about that information for now, but anyway. We want the Bluetooth address, we'll get the signal strength, we'll get the timestamp, advertisement, advertisement flags. We'll have a look at data sections as a list of data sections. What is flags? Not supported, dual mode controller, dual mode host, generic. So it's again more details. I'm not too fussed. I don't want to go too cluttered with all this info. Local name, we'll probably want, that's going to be the actual name. Manufacturing data, service IDs. Okay, so let's start with some basics. Let's start with a name. We definitely want the name. We'll have the name, the signal strength, the address definitely, and the time. Let's just start with them basics. So let's make a new class. And again, this is, for now, this is just in here. We can probably move this actual data class elsewhere or make an interface on the received information once we're happy with it. But for now, let's just make a new class. Call this DNA Bluetooth ALI device. Namespace is fine. Class should be public. Did I miss that on this one? No, that's public there. Control RG to remove the unused namespaces. Information about a Bluetooth ALI device. In here we want the, that's the same again, yeah. IntelliSense is definitely messed up. Public there by default, press space, and it just ignores it. I really want to change that behavior. I don't know why it's changed. Public date time offset, I presume. I should hope. Go to the received args dot timestamp. Please tell me it's an offset. Yes, I'd be worried if not. So the offset will be, let's call it broadcast time, I presume. And what we're going to do here as well in this class, because this is going to be, there's going to be a list of these devices. The point of this advertisement wrapper we're making is so we can start listening and just simply have at any point in time a list of discovered devices, and we're going to pass that list up to the consumer. So we don't want the consumer editing this piece of information. So this is going to be a value object. By that we mean these properties shouldn't be able to be changed after the object is created, therefore they're effectively read-only, and you can pass them outside of the application without them being edited, without worrying about the consumer editing the content. So all of them are just going to be getters, and we'll create them in the constructor. The address was a ulong address. There was a local name, so I'm just going to call it name in our case. That'll be, I presume, the name of the device. And then there was a signal strength. What's that advertised in? Where was it? Is it just there? That is a short. So it can be short. Signal strength. And I'm guessing that'll be decibels. Oh, I'm doing getter setters by default here. Force of habit. Decibels is usually like a negative number indicating 0 is perfect strength with no loss, and the further negative you go, the weaker the signal. So like minus 20 decibels is weaker than 0, minus 50 is weaker than minus 20. So the signal strength, we should probably say in dB as well. The signal strength and the actual way of writing it's that, but you can't really do that in camel case here. The name of the device, the address of the device, the time of the broadcast advertisement message of the device. Then we need to create a constructor, so let's just wrap that in public properties. And then constructor. Then we want the address, name, signal strength, which, if you know what it means, it's the received signal strength, and that's why it's RSSI. So we could use RSSI as a shortcut, or we could just do signal strength, but I'll use the standard term RSSI for that. Oh, and then broadcast time as well. And then just set the properties. So address equals address, name equals name, signal strength equals RSSI, and broadcast time equals broadcast time. That's the constructor. One thing I'll add to this as well, so we can do a nice easy console log, is I'll overwrite the toString. And now instead of just returning an object, we can create a string from this that looks nice. So we'll do the name first, and if there's no name, we will put no name. So, because I know some Bluetooth devices don't necessarily have a name. So if it's blank, then we will put out no name. Otherwise, we'll put out the name. That should be, why is that not happy with it? Oh, there we go. So we've got the name first, then let's just output the address. Just basically a dump of information, but it's better than, you know, having to construct this every time you want to show it. And then signal strength in decibels. User friendly toString. And I think that is everything we need in this class. So now in here, then, when we receive some information, let's make a new class. So device. And you're going to get these, I'm almost definitely presuming, on coming in at different times on different threads. So we're going to have to make this thread safe when we start creating a list. And we're also going to need a list. So we're going to need a list of discovered devices that we want to keep. And again, because this information is going to be passed out to consumers, we will want private read-only again, so it's created once and then we know it's not null. We'll do a dictionary internally, because we're fine internally as the private member just being a dictionary. When we expose it as a public property, it will be something else. But we'll make a dictionary that is unique to the address, which was a ulong, because that's the whole point of the address. It should be unique. And then we will pass in the entire device information. So we can keep track of discovered devices. And again, that new doesn't work. This is really annoying, this IntelliSense. Let me know if you guys get that issue with IntelliSense. This is a list of discovered devices. So this will be a list that we create here, effectively at construction time. And we keep our new class of information as the item, and it's in a dictionary keyed by the address of the item. When we expose it to the public, we will want to do a read-only, what shall we do? A read-only collection. So I read-only collection of the DNA Bluetooth device, discovered devices. It's going to be a getter. We're going to need some code in there though, so I'll have to break it out into that format. This will be, again, same description, a list of discovered devices. This read-only collection is just like a list, you know, a collection, a list of items, but that can't be edited. So again, it prevents the consumer from editing our list. We will need a thread lock at this point because nothing's currently, we can't do any locks without an object. So this will just be a private object, thread lock equals new object. That should also be read-only because we don't want that to change. Definitely don't want that to change. A thread lock object for this class. Now in the getter, every time somebody wants to get the devices, we're going to have to lock this list and convert it to a read-only list. So every time somebody requests it, they're going to get a new copy. It's up to them to use it, and then we don't care about it. We do need to lock though, because if the list changes at the point of querying, then it's going to crash. So if we now do return discovered devices to list first, control dot using link namespace, and this has as read only, and that should cast or not, it should cast to that. Discovered devices, oh, the values were in a dictionary, not a list. Get the values to list and read only. So practice thread safety kids. So we're locking that because this, at the point of values dot to list, this could crash if we got, say, an advertisement pop in this received, and then we add to that list. So we're going to have to lock every time we want to access this list. We could change a dictionary to a concurrent dictionary, which is thread safe inherently, but the problem with that is I don't really like how that works. That's got things like triad that will return false if it failed if something's tried to add at the same time. But we want to add, we don't ever want it to fail. We don't just simply want to go, oh, keep trying add and just ignore. So in this case, it's much easier to just lock this list than have a concurrent dictionary. So I think we're done with private members. And this should just return now a read-only list. Convert to read-only list. So that should be fine. Then where were we? So we got this device. So we wanted again to lock this code now because these are going to keep coming in on different threads. And we want to get the name. So the name was args.advertisement.local name, I think it was. Get the name of the device. We want to create the device. So we want to create the new class containing the info. It's in the constructor. So inside this constructor, I always like to explicitly specify when you're doing constructor initialization, instead of it just being a list of parameters, I like to explicitly tag it with the name. So if it ever gets renamed for one, it's obvious that you're assigning the wrong thing. If the order changes in the constructor, this will maintain that link. So I always prefer to explicitly specify the name in constructor arguments. That will be the Bluetooth address. Create new device class, device info class. Then we have the name, and you'll see why I'm doing the name separate in a minute, because I want to handle some kind of timeout to remove items from the list. We don't want this list to just keep growing every time we discover a Bluetooth device, but then a minute later it still be in the list even though it's long since disappeared or been turned off. So we want to kind of trim this list as we go. There was the broadcast time. That was in here again, somewhere, timestamp. And what was left? Name RSSI. So RSSI is the args dot raw signal strength in decibels. So that is a new class created. Now we just want to add this or update the device in the dictionary, because I'm presuming we'll get more than one call, like, you know, every 15 seconds that it's broadcasting, it's going to keep coming back in with the same device over and over and over. So the good thing with a dictionary is you can just do mdiscovered devices, go on the key, which is the address, the unique key, and just set it. So that would be the device. So if it doesn't exist, this is going to add it to the dictionary. And if it does exist, it's going to update it. So it's like a nice, easy way to not have to worry about, is this in the list? If so, remove and update. It just handles it nicely. So I think with that done, we now need to fire some event off so people actually know that we've received it. The consumers can do something with that. So we're done with locking the thread because we've accessed it, we've read it, and we've added it to the dictionary. So we can come out of the thread now. And we now want some events. So I'd say we'd have a new device discovered event, and it will pass the event information, the device class. So public event action DNA device class equals a default one fired when a new device is discovered. And what's it complaining about here? We haven't given it a name, have we? I keep forgetting to do steps today. New device discovered. Device, that's a funny spelling. Now the other thing, we're just firing it every time. We actually shouldn't do that. We need to check if we've had a new discovery, which we haven't checked. So at the top is new discovery, var new discovery. It will be if or if not, in the discovered devices contains the key args.bluetooth address. Yeah, so basically if the dictionary doesn't have any element by this address already, then it's new. So then in here now, we can fire the event. So if new discovery, then do new device discovered and pass in the device. And one other point here, if new discovery inform listeners, if we now call this, which is an event listener, or this is an event rather, the listener that then hooks in, like in this case here where we stop listening, if we were to hold up the thread here, then our class would also hold up here. Obviously this isn't the same event, but say this was in fact, let's just add it so you can see. Watch it, new device discovered, plus equals device. And if I was to now do thread .sleep and go to sleep for a long time, then when this fires this new device discovered, this thread here, if you will wait and nothing will progress to this line until that's done. So when I'm firing events, I sometimes like to spin them off to new threads, like just do task.run around this so that we're not held up by the things listening to our events. For now, I'm not going to bother, but it's something to bear in mind that you might forget that you're letting the listeners know that, something's happened, but your code won't continue until they, have dealt with that request and finished and come back. So we might change that to, something else in the, we might basically wrap this in a task.run in future. Just bear that in mind that, that's how it works. As well as the new device discovered, I think because this was an original function that whenever you get any piece of information received, you have an event, we should have one here as well, just called device discovered, I think. That if you want to listen into, any event at all, that you've got one. So let's just make one called device discovered. Copy and paste that. And this will just be called device discovered, and it's fired when a device is discovered. I mean, it's not technically a device, it's an advertisement, but obviously they think advertising is a device, so I think the naming's fine at the minute. We'll fire that event off as well. And I think we're good to give this a trial and see where we're at. So we're listening to a new device. So in here now we could console.writeLine. In fact, then you could also, because the device has got its overridden toString in the class, we can just do new device and then just output the actual object, and it will do a .toString on this, and it will then output all the information nicely. So I think that's enough to see if this actually does anything now. So we'll just put a breakpoint here and then just run it and see. And I don't know whether I've got Bluetooth on this machine or whether I've got any Bluetooth devices that are broadcasting that are low energy, but we'll see. So the watcher creates our new class, which then creates the dictionary that's read-only. The thread locker creates all these default events as expected, comes into the constructor, makes the watcher, hooks into the events, and then we hook into the events of our class, and we start listening, which should then start and inform listeners. So we should get a callback now in the code. And we've also, so we've got the start listening, so that's working. We've now got something received, so let's see what we've got. The args, so it's a not connectable undirected device. We've got an address. The advertisement has got no name, no real info on it. So I'm guessing that will come through as a device with not much info. And you can see as well, when we hover over device now, our toString works in the debugger. So you can see it's got no name, that's its Bluetooth address, and it's got a signal strength of -72, so that's working. We add it to the discovered devices, which we need to prune, otherwise these are going to just keep growing indefinitely. We fire the device discovered, it's a new device, and we fire the new device discovered, and this is going to keep discovering devices or getting new broadcasts. So let's just hook into new devices only. And let's see how many times this runs. We've got that one, no name. No name, no name. We've got lots of, oh, that's got a name. And I'm guessing these are all my light switches. I've got like Bluetooth light switches. So you can see this is working. We're discovering devices now. New device with no name. The other thing as well is if the device comes in, I've just thought about that. When we get a device, we're just checking if it's newly discovered, if the Bluetooth address has changed, but things like the signal strength will change. So we might want to update this if the signal strength changes. We probably still want to update it constantly so the information's as fresh as possible. So I think this add an update thing wants to happen anyway. Actually, it'll have to happen in there. Oh, we do anyway. So we get the information and we always add or update it. But what we do need to do then is, well, we could let the, we could add another event, say when the name changes, if it comes in and we have no name. So name changed. And you could do one for that signal strength changed. So you could add more events to inform people of changes, but I think the signal strength changing is going to be a bit overkill. But perhaps if the device name changes, like I've noticed when you add headphones, you discover them, it says no name, and then it pops up with a headphone name afterwards. So that's probably, it's broadcasting one thing, then broadcasting a different way and including the name in. So the name's changed. We only want to let them know of a name change if it's already been discovered. So it's not a new discovery. And the name isn't empty in the one that's coming in. Otherwise, we don't want to say it's changed from. We only want to change the name if it's blank and goes to something else, not the other way around. We don't want to, have a name and then it broadcasts that it's got no name and we lose that name. So I'll exclude if it's blank. So if it's not discovered, name changed. If it's not, if it already exists, and is not a blank name, and the discovered devices based on the Bluetooth address, which if it's not new, we know it's discoverable, so we know this will be something. So if that specific piece of information .name isn't equal to the name that we currently have, effectively as it changed, that will be it. So, and the name is different. And I don't know whether any of the ones I've got here will fire on that, but we can certainly add it if so. So if name changed, let's add a name device name changed. inform listeners. And we could pass the old name and the new name, which, yeah, guess we might as well. We could just do the old name, and mind you, at that point, let's just pass the new name, screw it. We can always update that. So we want device name changed as an event. That would be the device name changed. Fired when a device name changes. And that's in there. Let's now hook into it, and let's see if any of those hit. Device name changed. And let's just run that and see if anything happens and see what we discover now. Breakpoint off that. So we've got 1 with a name, 5 without a name. Just leave this running for a little bit, see if we ever hit that kind of name change thing. Maybe we won't on this. I can try and maybe turn some Bluetooth headsets on and, oh, there you go. Device name changed. Something's wrong there, because it's now constantly telling us the device name's changed for the same one 3 times. And it's the same address. How's that fired 3 times? See, that makes sense. This doesn't necessarily make sense, because that's the exact same address firing the name change 3 times. Oh, I know why we didn't actually update the name. So in here, I was thinking ahead here with the name that if it did change, we'd want to update it, because what we don't want to do here is, if we've detected that the name has changed, or rather if we've detected that the current name is blank, but the existing Bluetooth already had a name, we don't want to override it with the blank name. So we need to protect against that here. So if current name is blank, but if new name is blank, but current one is not. So if string is null or empty, the name, the current name, and the discovered device is based on the Bluetooth address dot name, rather new discovery. First we've got to check that. So, or if it's not a new discovery, so it exists. So it's currently blank and it's not newly discovered. So basically the same. Oh, actually, that is this exact same thing, isn't it? So, but with this flipped around. So we've got to do that check separately. Yeah, so if the current name is blank and we already have one, then we don't really need to bother checking if the new one's, if the existing one's blank or not. So if the new name is blank and we already have a device, don't override what could be an actual name already. So then we just need to set the name to the discovered devices of the Bluetooth address name. So basically it's just saying if a blank name comes in, use whatever name we currently have. That should keep the name the same. So now we should see hopefully just a name update only once per device name. Okay, we're not getting on here on that. Let's just reset it and try again. Okay, I give up trying to get that to happen. So, I mean, it happened the once. There was a name change, and we've kind of made the obvious logical change here now. So as that's a minor thing that I was just hoping for to see, is the name updating. One of you guys can test that for me, see if that works, and we can always fix it if it doesn't, and make some tests after to, you know, like a unit test on this specific, you know, block of code to whether it correctly detects name changes. I'm not too fussed. So we're discovering the device. We've got some info on it, which is the ideal thing we wanted. The last thing I want to do here now is to prune any any devices. And also, thinking of it, when you start listening again, you want to, so if it's not listening, there's nothing in. When you stop, then in that case, we want to clear the list. So if it's not listening there, do a stop. Now lock the list and clear any devices, which will be discovered devices.clear. So that will just make sure we don't maintain the previous list of devices when we're stopping and starting. It correctly handles the state. So to handle kind of timing out, so like I say, as the list adds, we're never going to remove items at the minute, and we want to. So we want to have a timeout value. So that will be a public property, public int, call it heartbeat timeout. And that will be getter and a setter, and let's default it to 30, say. This will be the timeout in seconds that a device is removed from the discovered devices list if it is not re-advertised within this time. We'll default that so the consumer doesn't have to be bothered with it. Obviously, there'll be a new event now as well. So it will be the same as this, that whenever we remove a device, which will happen if we're pruning them, we want to be informed. Find when a device is removed for timing out. So it will be device removed, or let's call it device timed out. And the point now is, when do we decide to clean up? Well, I'd say there's two places. One would be every time somebody wants the list of discovered devices, I would clean up, or should I put clean up timeouts. And what we could also do is obviously have a thread running, but I'm going against that, because then you'd have to start the thread up, say in the constructor or somewhere, and then it's keeping track of when to end that thread so it isn't running forever. So instead of just sitting on a timer and then constantly checking, we're just going to do it at the important times, which is when you want the list of discovered devices, and also when, I've got to paste that back in. Where else was I thinking? In the private methods. When we receive one. So that's a good time to clean up the list. So in here, we could just say clean up timeouts. It's just a good time to do it. So it just keeps that list nice and pruned, so that when we're about to add a new one, we don't add one that, it's timed out and we don't duplicate, if you know what I mean. So we'll do it there, and we'll do it when you get the list. So this will prune any device. In fact, this is a private helper. This needs moving. Prune any timed out devices that we have not heard of. Move that again, back and forward. Private methods in here. So what do we do? First thing is to obviously lock, because we're going to be altering the list. So while we're cleaning up, we don't want anything to happen to the list. We need to freeze it at that point in time. We want a threshold in terms of the time. So the date time dot now, or UTC now, minus a time span from seconds of the heartbeat will give us effectively the date in time that if a date and time that if less than means a device has timed out. So if anything's less than this threshold, then it needs to be removed. So to do that, we'll do discovered devices dot where the value, which is where all the info is in the class. If the broadcast time is less than the threshold, That's how we select on the where. Then turn that to a list, and then for each over that list, so it keeps it nice and easy. So any devices that have not sent a new broadcast in the within the heartbeat time, remove device. That will be discovered devices dot remove, and is the key, which will be the device dot address or value key rather. We've got the actual key itself there, and inform listeners. So that will be the device removed call event. I did make it, didn't I? Device timeout, that's what we called it. And it's the device.value in this case. I think that's it. And did we hook into the device removed call or device timeout? No, we didn't. So let's hook into that. Device timeout. Timeout. We could also change the color here. So just do console.foreground color equals red, say in this case. You could do one for each of them. I could do started listening could be dark yellow. Stopped listening could be gray. New discovery should be green. Device name changed can be bright yellow. And red. So there we've got a bit of color, a bit of timeout. Now let's just drop this value to say 3 seconds so that devices should constantly get pruned and re-added as we get messages so we can see it all happening. So new devices. One of them should be pruned anytime now. There we go. 8.6 something comes in. Pruning. So yeah, you can see it happening. Basically, we're receiving broadcasts from the devices, and then because they haven't rebroadcast within 3 seconds, which you wouldn't expect them to, we are then pruning them out, and then we're getting the next packet from them, and they're constantly going around in circles and re-adding, which is good. So that looks like it's working how we want it to. Change that back to 30 seconds. Let's give it one more spin up. So we have 1, 2, 3, 4, 5. 5 devices there. 7 devices. 8 devices. And then let's see if any of them time out. I'm guessing they'll all respond within 30 seconds. Some maybe 60 seconds, but this is all I'm doing for testing right now. The main thing is we wanted to see this kind of discovery, and I'm guessing this address is going to be the unique thing that we need to do something with, because we're then going to have to connect to these devices and then try and read more information about them than what we're getting at the minute. But this is a good start. So tell you what, let's just add one more thing to the little class. Let's just do a little while loop here. So let's just do while true, console.readLine. So that'll just pause until we press enter. Then when we do press enter, we'll get the devices from the watcher.discovered devices, which should be the devices at this point in time. Get discovered devices, and then let's just dump them out to the console. So console.foreground color equals color.white. Let's just do normal. Console.writeLine. Right line, and we will output the number of devices. So that will be devices.count. Devices, and then we'll output all of them for each device in devices. Console, we will make sure, just do console.writeLine device. Just keep it that simple. And then we'll never get to this point. In this case, we're just going to do while true, which is fine. So now we can press enter at any point to read what our class thinks are discovered devices. So if I press it now, you can see it thought there was 5 devices at that point in time, which is correct. I press it again, there should be the 6, which there is. So it's like we're just reading. This is a nice, easy way to mess with the code and see it working. So now you've got 8 devices there. They are, so I'm quite happy with this. Seems to all be working as I want it to be working. So I think, given that will do me for now, I think. I know it's just the first implementation and we've got to abstract this away and create interfaces and do a lot more testing, but it's clean, it's organized, it seems to be working. It should be thread safe. I'm happy with this unit of work now. So let's get this commit to code. So you can see in the Blueberry app here, we have our code. So we first stage all, minimize that, expand all. Let's take a look. So we've got the Playground, which is a .NET Core console app. This I'm not too fussed about. This is just a little playground. Don't worry too much about structure or cleanliness in here. Just keep it relatively clean. So that one's fine. The main solution is obviously adding those 2 new properties. That's fine. This one is the value object class, which has information about a Bluetooth Low Energy device, all the info, the constructor, and the toString. That's the actual solution, the project file, which is fine and clean. And this is the main code here, which is our implementation of the watcher. We've got it wrapped in private members, public properties. They are read-only. Now a chord, that's a getter, so it's read-only, yep. Listening is a getter, so that's fine. Heartbeat can change at any point, so we're fine with that. Public events, yep, we've got all them. Constructor creates the watcher, listens to the receive, listens for a stop. And you get info, you clean it, create the device. Is it newly discovered? Has the name changed? Lock the thread. Get the name, check if the name's changed, create the device, add it to the list. Discovered, name change, yeah, that all looks good. The cleanup, if the date from now minus the number of seconds is less than that, remove. Yep, I'm happy with that. Start listening, returns, starts. And I mean, in theory, this could try and call start twice here, because you can call this from multiple threads. This is a check that isn't really locked, and then we can call start twice. So starting and stopping actually both need locking. So let's just jump back over to the implementation here. Now we have a thread lock for the class. I'm just going to reuse that, to be honest. I'm not too fussed. So let's just lock the whole call. Just all it's going to do is hold up for a split second while we check that and return, or while we start and while we inform listeners. So I'm not worried about informing the listeners that we started, but I am worried about that being not thread safe there. So let's just add that into it. And we're locking there to clear the list, so we might as well actually do all that. There we go. Stage that, go to the bottom again. And then we're locked on the listening and the stopping and starting. Yeah, so I'm happy with that. So this will now be implement a Bluetooth LE advertisement listener. And yep, I am definitely happy with that. Commit, push, and we are done. So now we have a Bluetooth class that can discover Bluetooth LE devices and keep them in a list of active connections, as well as remove them when they time out. So that's a great start. The next thing I want to do is see if I can discover these actual Bluetooth devices I've brought for reading glucose and then make a connection to them. Hopefully you've enjoyed one of these old school, if you will, long coding videos. I know a lot of you seem to think I'm not doing them. It's simply a fact that the way development happens in the real world is all these steps I'm doing happen. And in the last series, most people complained that I'd cut some steps out here and there. So you've got to find this balance where you appreciate that a lot of what I will do in this project is not going to be coding. It's the whole business model. It's not just a developer's take on a product. It's an entrepreneur's take from the top level of actually making a full application. So that's going to ultimately potentially lead to trying to get funding from governments, maybe, to advertising, to promotions, to many other things that aren't just software development. This course is about the entire product as a whole. So you could, in theory, start your own business. So hopefully people start to appreciate that and stop leaving comments like, when are you going to code when I do a non-coding video? Again, you've got to remember, this is all for free. I'm not earning money doing this. I want to enjoy what I'm doing and give away my knowledge. And if you're just a developer on this channel, then simply sit by and either ignore the videos that aren't code or watch them and learn something from them. But please do try and not keep commenting about when's this going to happen, when's that going to happen. It comes as it comes, and I'm trying my best to do all this, and hopefully you guys appreciate that.